In this video, we're going to be looking at different options or different formula options for finding the area of a triangle, or in some cases a regular polygon. So let's look at what we have here. So it's the area of a regular polygon. That means all sides the same length, all angles same measure. It's given by this formula. The area is 1/2 A, where A is the apothem of the triangle and P is the perimeter. Okay, so the triangle has 3 sides. Of course, you can find the perimeter by just setting all 3 sides. The apothem, I have the diagram here, goes from the center, and this is a regular polygon, in this case an equilateral triangle. All sides the same measure, so if I call this side S, this side is S, this side over here is S. Now this side right there, from this point here where the base of the apothem is, to this side, it's S/2. So basically an apothem is a perpendicular drop from the center of the polygon, in this case right here. And that's the center of the circle in which this triangle is inscribed. So if I draw a circle passing through the vertices, and it's not going to be a nice circle, but go like that. This is the center of that circle, and the triangle is inscribed inside. So each vertex is supposed to be on the circle. So this right here is really it's called the radius. That's the radius of the circle. And then this side, and this is actually a right triangle, because when you drop this apothem, this becomes a right angle here. So these 2 sides are the same length here. Half of whatever the side is. In this case it's S, so each side is S/2. So we can use, get this out of the way here, this triangle to find the length of the apothem. So when I drop this radius this way to this vertex, it divides this angle. Each angle here is 60 degrees. Okay, equilateral triangle, each angle 60. So this bisects this angle over here, so this is 30. This of course is 90 because this is perpendicular, so this angle over here is 60 degrees. And this of course is 30 over here. We can use a 30-60 right triangle to find A. And we don't have to use trig here, but there's going to be times where you're going to have to use trig. So let's just look at this triangle right here. And I'm going to say that I'm going to use the tangent here. The tangent of 60 degrees, that's this angle right here, is the opposite over the adjacent. So looking from the view from 60 degrees this side, opposite is, in this case, is S/2 over A. And the tangent of 60 is the square root of 3. And I'm going to multiply both sides by A here. So this is going to leave me on this side S/2. And I want to solve for A here, so I'm going to divide or multiply both sides by 1 over the square root of 3. So this will give me then S/2. And this will be times 1 over the square root of 3. But we have to rationalize this, so I'm going to multiply the top and the bottom here by the square root of 3. So that's going to give me the square root of 3 S here. The bottom by the square root of 3, this gives me the square root of 6. 9 rather, I should say. So that's going to be 3. 3 times 2 is 6. So this is the apothem here. So using this formula, I can find the area of an equilateral triangle. And that area will be given by 1/2 the apothem. So in this case, let's put it in there. It's the square root of 3 over 6 times S times the perimeter. So we have 3 sides the same length, so this will be times 3S. And then you just do the calculations. So let me just simplify this a little bit here. Say this is equal to 1/2. Or let's say make it, multiply the 2 and the 6 there, make that 12. And of course you could reduce it also because you have a 3 up here, so this would be 12, and then a 3 make that at 4. So let's just make this 4 here. Then S times S is S squared, so this gives me the square root of 3. S squared. So we brought it, here is one term, so I could rewrite this, the square root of 3 S squared over 4. So this gives me really a formula for finding the area of any equilateral triangle. I actually derived this formula in an earlier video, and I'll put a link to that in the video description. I didn't use the apothem there. What I did, I basically did the same sort of thing. I didn't use trigonometry in that particular problem, but I used the base. I used the regular formula for the area of a triangle. So your general formula for any triangle doesn't have to be isosceles. Now this one only works. This one only works if it's an equilateral triangle, this formula here. But your regular formula for the area of a triangle is 1/2 the base times the height. Now if you have a right triangle, of course you can use either of the legs as the base or the height, because all you got to do is multiply those and then take half of that to get your area. So suppose here that you have a triangle and has a side of 10. Say the length of each side is 10. You can do it in steps like this, where you just plug in the apothem, which is right here in the middle, and then this of course represents your perimeter. Or you can just use the formula this way and say, okay, if you know the side, it's 10 squared, that's 100. 100 divided by 4 is 25. So the area of an equilateral triangle that has one side of 10 units is 25 the square root of 3 times the square root of 3, which is 43.3. So this comes out to 43, and that's square units, 43.3. So again, this formula I derived in an earlier video, but I didn't use the apothem here, and I came up with this formula. So this tells you that you can use this formula to find the area of any equilateral triangle if you know the side. They're all the same, right? So you need know one, you know them all, and just plug it into this this particular formula. Now this tells me in general that if you have a regular polygon, so that could be a pentagon, hexagon, could be a polygon with 20 sides, this formula is going to work. If you can find the perimeter, and if the apothem is not given, you can find it the way I did it here. Okay, with actual numbers. I did it here just using S as the length of the side. But if you're given numbers, it works the same way, except you just plug in the numbers. Now to clarify this a little bit, let's look at. Suppose I have a square, and this is say 4 units, and this is 4 units, and you want to find the area of the square. Okay, we're not going to mention the apothem enough to start off here. We know the formula for the area of a square, or the area of a rectangle. It's length times the width. Okay, length times the width. So in this case, if I just use that formula, this is 4 times 4. This is 16. This, of course, will be square units. Now, let's suppose I want to use this formula here. Now, keep in mind that when we say this formula here, area is equal to 1/2, anytime it has apothem in there, anytime you got to use the apothem, you can only use this formula if it's a regular polygon. That means all the sides have to be the same length. All the angles have to have the same measure. Well, in this case, a square is a regular polygon because all 4 sides are the same. 4, 4, 4 all the way around. All the angles are 90 degrees, so it works. So let's find the apothem here. Here we don't need any fancy trig formula here to get it. The center point right here is your center. So the apothem would be perpendicular to the midpoint of the opposite side, any opposite side. So I could go this way. That would be, this would be A. The length of this would be A, the apothem. Or I could draw it to this side over here. That would be A. Or I could go this way, I could go up. So now if I use this formula, if I want to use the apothem, I say, okay, this is going to equal to, according to the formula, it's 1/2 the apothem. So what's the apothem? Okay, this is 4 over here. So this is the midpoint, so this is just 2. Okay, that's 2. So it's 1/2 times the apothem A, that's 2, times the perimeter, that's 16. Multiply this out. Well, 1/2 of 2 is 1, and 1 times 16 is equal to 16. You can see it works. It works. Here we don't need a formula to calculate it because it's a simple square here. We can easily say, okay, there's the midpoint, and if you drop it perpendicular to any side of the square, it doesn't matter which one, as long as it's a perpendicular, that length is going to be 2 units, and that's going to be your apothem. Now, I couldn't do this with a square. With a square, to find the area, you have to use a regular formula. Length times the width is going to give me the area, because a rectangle in general is not going to be a regular polygon. Normally the length and the width are not the same. Right? A square is a special type of rectangle where the length and the width are the same length. But keep in mind, you can only use this formula. You can only use this formula. Here, area is equal to 1/2 the apothem times the perimeter if it's a regular polygon. I also want to look at this. We go back, this triangle here. Let's look at this isosceles, not isosceles, equilateral triangle. Here, again, I just want to show you some options because this comes up also with polygons. There's going to be different ways to find the area once you get into polygons with 5 sides, 6 sides, 7 sides, and so forth. So we have a formula for finding the area of a equilateral triangle. Okay, we just did it using two methods here. We could find the altitude here. I could drop this down instead of using the apothem. I could find this. This would be 5. This would be 5 here. This would be 60 degrees. This would be 60 degrees, and this angle over here would be 30 degrees. It divides it. But I wouldn't need trigonometry for this one to find the altitude. And I would just say this is n equal to h squared plus 25 is equal to 100. Using the Pythagorean theorem, if you have a right triangle, the square of the hypotenuse, which is always opposite the 90-degree angle, that's this right here, drop the perpendicular to find this altitude. It's going to equal to, anyway, that square will equal to the sum of the squares of the other 2 sides. So then this would be h squared, subtract 25 from both sides, this will give me 75. And take the square root of both sides, h will equal to the square root of 75. And 75 is 25 times 3, and the square root of 25 is 5. So that would come out like this. Square root of 25 is 5, and this would be a 3 here. So now we have the base. If you have, again, for any triangle, doesn't have to be equilateral, but for any triangle, this formula will work. 1/2 the base times the height. So in this particular case, this would be 1/2, and the base of the triangle. Okay, now in this case, the base is 10, because before, the other problem, we were looking at this triangle here. But here, we're looking for the large triangle, so the base is 10. So it's 10. That's the base. And then the height is times, so this would be 5 times the square root of 3. 2 goes into 10, 5. 5 times 5 is 25. So the area of this triangle is 25 times the square root of 3. And that's the same thing we got using the other formula with the apothem and so forth. You multiply 25 times the square root of 3, this will give you 43.3. And this is area, so that is square units. That's square units. Okay, so again, in this video, what I'm doing is giving you options, because this will carry out to some of those other formulas when you get working with regular polygons or irregular polygons, and you want to find the area of the figure. There's going to be different techniques that you can use. Got the same answer. Now, another formula you can use, and I've derived a lot of these formulas that I'm going over with, and I'll post videos in the description just in case you want to look at those. It's nice to know a formula and how to apply it. Sometimes it's even nicer if you can derive the formula on your own. So in this case, there's a formula, and I actually went through and showed how to derive this formula. But here I'm just going to give it to you. It says if you have a triangle, and again, in this formula, again, it doesn't have to be equilateral. It can be any triangle, as long as you're given two sides and the angle included with those two sides. Okay, so here we know all the angles are 60. So if I use 10 and 10 here, then I know that this angle is 60. And this is what the formula tells you. If you're given any triangle, two sides along with the included angle, in this case 60 degrees, the area will be given by 1/2 times the product of those two sides. So it's 10 times 10. I'll just put 100 here. 10 times 10 is 100. And the sine, trigonometry here, the sine of the included angle. There you have it. And then you just go ahead and put it into your calculator. Now actually here, you don't have to really understand trig that well to figure this out, as long as you know how to set your calculator to degree mode, because sometimes the angle might be given in radians. You want it in degree mode. So get your calculator. Doesn't matter which calculator you have. Most of them are going to have the trig functions there. So I'll just do here 1/2 times 100. I'll say that's 50. 50. And then that's going to be times the sine. My calculator is set to degrees, so no issue there. Sine of 60. And there we have it. Same answer. 43.3 square units. Again, for this formula, doesn't have to be equilateral. As long as you're given the two sides and the included angle, you just plug it in. 1/2 times the product of those two sides given, multiplied by the sine of the included angle. Now, and again, this formula applies for any triangle. It doesn't have to be equilateral. I'm just trying to work the same problem so you can see we get the same answer. So for this one, it's called Heron's formula. So for Heron's formula, you need to know the length of all the sides. Now in this case, it turns out to be they're all the same length, but again, they don't have to be as long as you're given the sides. And what you do is you add the 3 sides. In other words, you're taking the perimeter, dividing by 2. So 10 plus 10 plus 10 is 30, divided by 2 is 15. And then this is what the formula tells you. The area will be given by the square root of S, where S is 15 in this case. Again, the lengths don't have to be all equal. You just add them up, find the perimeter. So it's S times, and then it's S minus A, where A is one side of the triangle, times S minus B. B is the second side. S minus C. So all you're taking is adding the sides, dividing by 2. You're taking the square root of S, and then times S minus one side, times S minus the other side, times S minus the third side. Compute that and then take the square root. So let's look at what we get in there. So this is going to be the square root. It's 15, and first one, A is 10, so it's 15 minus 10 is 5. 15 minus, again, is the same thing, so it's going to be 5. Again, S is 15 minus 10 again is 5. This is equal to, this will be 3, and then 15 is 3 times 5, so that's going to give me 4 5s. So I can just put 5 to the 4th. So that's 625. So the square root of 625 is 25. That comes outside the radical. And I get 25 times the square root of 3. Which is the same thing as do the calculations we got earlier. 43.3 square units. Now, is there some more formulas? Yes. There's at least 2 others that I know of where you can calculate. Again, these formulas that I'm using right now will work. It doesn't have to be an equilateral triangle. Since I started with an equilateral triangle, I wanted to use it for all the different problems, all the different formulas rather, so you can see we get the same thing. So just giving you some different options, and when you get into more advanced areas, finding, say, again, polygons of, say, 5, 6, 7, 8 sides, you're able to find the apothem and use the formula for that. Okay, because if you have a regular polygon, then you want to focus on 1/2 the apothem times the perimeter. Get a little bit here with the triangle and for the square, just to give you a taste of what it involves. We'll get into more difficult problems in the next video. Thanks for watching. We'll see you next time.